I'm going to roll. Do you see my screen?
Yes.
Okay,
Yep.
Thank you. Get some verification. So this is the third and the final in this series, of this particular series anyway, of the exhaust after treatment, our EC490 exhaust after treatment system. And excuse me a moment, there we go. Always seems to hitch up on me at the very beginning. So part 3. Just in keeping with what I've been doing, I'm going to talk a little bit about the planning. And this is the storyboard from a couple of days ago. I rearranged that. I didn't take another picture of it because I'm going to kind of gloss over it here for a little bit. But this is our typical planning process. I want to get right into the comments. I had, there were 14 comments and to the questions. And I wanted to go over something here that, you know, maybe the instructor set you up to check what you were reading and the amount of research that you're done. And maybe the instructor glossed over the decomposition tube a little bit. And so I want to show you, or you're seeing the comments that came out of that. And if you get comments like this from your students, this is a good indication of something that maybe you need to go back in and look at again. And this is where I find this form of assessment really important for the student and the student learner. So that's what I'm going to concentrate on this presentation with. I've got a couple of videos to show that are very short. Rick and I worked on the sound this morning, so hopefully the sound is a little better than it was on the first day. But there's some recordings that I've done with the courseware for the EC490 in the exhaust after treatment portion of it that actually go into a bit of the decomposition chamber, swirl chamber, whatever you want to call it. And then I've also found an old Cummins video that I've just taken a snippet of and put in here as a link. So you'll be able to go back and go through that. Plus some other links to the other sources that I've mentioned. But especially the Ford document, the 207 pages. Some of the questions that we talked about the other day are buried in that, like what are the temperature sensors doing and what are they reporting back to the computer and how that all happens. Very comprehensive document that you know you just go into as deep as you need to, I think. Many of the same answers, and so we can see the way the comments come back in. So this is a great way, I think, to get going. Now, I'm going to key up this Cummins video. It's from 2010. You know, it's 10 years old, but the description of the DEF operation is captured within about a minute, minute and a half here. And the link above, and also the whole video itself, and we'll see if this works. The link should take you right into the 10-minute and 59-second portion of it. And let's see if it works.
Selective catalytic reduction, which is the second part of the after-treatment system. So talk to us about SCR.
Yes, good point. Let me talk about SCR. Where the DPF takes care of the soot, the purpose of the SCR device is to reduce oxides of nitrogen, or NOx. In order for the SCR system to reduce NOx in the exhaust, a reactant or fluid is required. The industry name for this fluid is diesel exhaust fluid, or DEF. Here's how it works. Between the DPF and the SCR catalyst is a connection pipe where a dosing valve introduces a small mist of the DEF into the exhaust. DEF is a composition of urea and water. the DEF breaks down into ammonia in the exhaust. So as a small amount of ammonia enters the SCR catalyst, a chemical reaction takes place between the ammonia and the NOx to form nitrogen and water. And it's the nitrogen and water that exits the exhaust pipe. That's how NOx is reduced to near zero.
Okay, I understand generally how the SCR system works, but you mentioned a new fluid, DEF. How does the driver operator, what do they know about this fluid?
Good question. There's a new lamp and gauge on the dash, much like your fuel gauge, that indicates quantity of DEF on board. At varying levels of DEF, a lamp will illuminate to indicate low levels of DEF. And if the DEF lamp begins to flash, the DEF level is critically low.
Okay, I understand that. I think, though, Mike, there are a few more points or tips that folks in the fire industry want to know about 2010. Tell me more about DEF.
DEF is a 32.5% urea water solution. It's non-toxic, non-polluting, non-flammable, and it's safe to handle and store.
Okay, enough of that. Let's go back to presentation. Okay, let's get back in. Looks like there we go. So let's look at the system. Once again, I want to show a new tool. I haven't really mastered this tool at all yet, but and we'll see if it even works. It's an inking tool, and I can change my pen and draw through the system. And of course, here we should swirl and we go on out. When I'm dealing with students, I like to be able to, on a static screen, be able to show a progression. And so we can see the constituents coming in, the DEF is being injected. This is what we talked about. And then the decomposition tube is actually mixing that all together and then separating out the ammonia so that it can react properly to cut our oxides of nitrogen, our NOx. So here's just another slide that I put in yesterday, but it actually shows very graphically the SCR catalyst system. Now maybe this slide makes a little more sense. I'll be quiet for a minute while you read 1 through 4 slowly. Okay, so now here we're at a video that I've constructed to follow the course materials for the EC490 exhaust system trainer. This is a video for students and also the instructor to begin to lead them through the assignment. So this is just a minute or so here, so I'm going to play this.
Assignment 5. This is the 5th of the series of assignments.
You may have to bounce your volume up a little.
Aftertreatment system. The diesel exhaust fluid, or DEF, injector, and spiral mixing chamber are located next in this system. In this assignment, the exhaust gases and other components that travel through the mixing chamber or decomposition tube need to be identified. This is the place to start talking about what is happening to the gases as they pass through this system, and why are there 4 components entering the system and 6 components exiting the system. What is in the decomposition tube? The chemistry lesson continues. Assignment 5. This is the 5th of the series of assignment videos for the EC490 exhaust aftertreatment system. The diesel exhaust fluid, or DEF, injector, and spiral mixing chamber.
Sorry, that's a repeat. So just to recap, we show where the what's coming in and what's coming out. The next video is going to show what goes into the selective catalytic reduction unit. Remember that the architecture of the trainer changes directions here. So instead of the exhaust gases flowing from left to right, they're going to flow from right to left in the next example.
Assignment 6. This is the 6th in the series of assignment videos for the EC490 exhaust aftertreatment system. The core of a modern diesel exhaust system is a urea-based selective catalytic reduction, or SCR, system that contains a ceramic catalyst wash-coated with a proprietary substrate. The term selective in SCR refers to ammonia that prefers to react with oxygen in oxides of nitrogen, or NOx, instead of other oxygen contained in the exhaust gas flow. The SCR is where that NOx is generated from the process of combustion and are removed from the exhaust stream. The diesel exhaust fluid, or DEF, also called the reductant, is injected into the exhaust upstream of the SCR catalyst. This DEF reductant is a mixture of 32.5% urea and 67.5% water that is split into carbon dioxide and ammonia by the heat of the exhaust gases. The ammonia is the reduction agent in the SCR system. As the ammonia and NOx pass through the ceramics SCR catalyst, a reduction reaction takes place, and the ammonia and NOx are converted to nitrogen and water, and the gases efficiently revert to their original state. The SCR system works efficiently only when the catalyst temperature is between 570 and 750 degrees Fahrenheit, and the DEF fluid is of proper quality. The engine is able to run leaner and more efficiently because of the efficiency of the SCR system, eliminating the high NOx levels associated with lean combustion conditions. This is the place to continue talking about what is happening to the gases as they pass through the system, and why there are 6 component gases flowing into the system and 4 components coming out. In this assignment, the exhaust gases that travel through the SCR need to be identified, along with all of the components. In assignment 7, we'll learn about the diesel particulate filter, or DPF unit.
Okay, so there we've gone through what I put in for assignments, how the gases move through the selective catalytic reduction unit and the decomposition tube. So we've taken that section, this small section, I would call it a little more than a third maybe, of the exhaust aftertreatment system, and given that description. Then the exhaust moves into the diesel particulate filter. And this is where the next lesson would start, is to everything about diesel particulate filters and how it's going to remove the particulate, and then how it's going to go through a regeneration cycle where that particulate is turned into ash. So instead of soot, we're going to burn it down to ash. If you could visualize, and we have to be careful with our visualizations, right? But if you could visualize a set of briquettes that you've started for a barbecue, and when they're all done, their resultant leftover is ash. That's pretty much what's going on in the diesel particulate filter as well. So some folks asked about resources. And for ease of my building this session, I put it on my personal website. Normally when we share stuff out, it'll be through the ConsuLab website and it'll all be there. But if you click on this part, if you download the PowerPoint, this is a hot link. I could click right to this page, and then all those things highlighted in blue, those are all links to information that you've been asking for. So if you go down to the bottom of the screen, DPF regeneration FLIR recording number 1, that's done on ConsuLab ZM140, which is the 6.7 liter diesel engine, with the very same exhaust after treatment as we have in the EC490. So those recordings there are at the end. Those were done some years ago at Bellingham Technical College. I'm not going to play those. This is part of my shtick as an instructor, is I want my students researching on their own and getting some information. Sometimes you have to hand it to them, but you know, they need to take charge of their own learning, right? So my view of learning involves also reflecting on your learning. We call this thinking about thinking, and being able to put it down on a piece of paper so that you can refer back to it. We often take notes and we put them in various places. What I had the students do, and I know that there are several of you in the watching today that have learning portfolios set up. This is really a good place for the students to show us what they've learned. And I put Tom Hicks's up here. Tom was a more mature student, had some excellent writing skills, so I often highlight, you always want to highlight the best, you know. So I often highlight Tom's blog, and as an example of what I expect in a learning portfolio. It's a bit of telling a story. Maybe it's filling out a warranty report. I haven't found a shop owner yet that fights me on this, that technicians need to be able to write, and they need to be able to tell a story so they can get paid for it. The shop can get paid for the work. So that link is there. You can go in and look at Tom's stuff. You can contact me off screen, whatever, for reflection on learning. And that's all I have in the PowerPoint presentation. And I'm going to unshare my screen. And I would like to now, with the remainder about 10 minutes, is throw it open and let's have some discussion about, I'd like to talk about not so much me or the presentation, unless you've got something that I do that's quirky and you don't like it. But I more want to talk about student learning and you know, the offerings that ConsuLab has to enable you to end up with better outcomes for your students. And with that,
Joe Hart was wondering if 32.5% is constant.
There's a range. Kevin Looney gave that in the chat yesterday. I think it's plus or minus 0.5% or something. But in that resources pages, Joe, there are cell sheets from DEF manufacturers. There's the ISO standard for DEF that everybody follows. So one of the questions that I saw on the replies was, is all DEF fluid the same? And it's supposed to for this application. Now there are some heavier duty applications where the mixture is different. So in heavy shipping, where they're using a large amount of diesel exhaust fluid, I believe the percentage is 40% urea and 60% water. So it's a richer mixture, if you will. So they don't carry as much of it on or ship or on board. Oh, like Tony Martin gets me stuff on Caterpillar. He's at a big mine up in Alaska, and their latest in-dump ore trucks, I believe they're 793 Caterpillars, have huge SCR systems on them. I mean, the SCR system on one of those is about as big as the bed of your pickup.
Damn.
I mean, it's a huge. Well, you have. I mean, it's a 3524 engine, maybe even bigger than that, and you've got a lot of air and fuel in. You have a lot of exhaust out that needs to be treated, but it works in the same way.
Jeff, that was essentially what I was going to ask is going back to the EC490 is relatively small, comparatively speaking. And so when we talk about it in terms of massive equipment with massive engines, do they just scale up the same technology?
Yeah, it is. It's the same principles. And the issue of the order of the diesel particulate filter and the selective catalytic reduction unit, I first looked at it and go, well, that's different. And yeah, it is. And I see different manufacturers use it in different orders. Somebody asked in the forums questionnaire I sent out, isn't there a standard? How come all the manufacturers don't have the same architecture? Well, EPA gives them a mandate to, it's in a closed bag, right? They call it bag testing. So they measure everything that comes in the engine and it goes out the engine. And it's all related to, see how I get distracted. It's all related to engine size. Could I have you mute, please? There we go. It's all related to exhaust in and air intake in and air intake out to clean the gases to a specific amount, usually in grams per horsepower hour. Okay, a lot of this is in grams per horsepower hour, and I don't get too much into that because then you're starting to get into wah 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 with the students. But that relation, I think, should be explored. The bigger the engine, the bigger the aftertreatment system.
Hey,
Jeff,
just
Richard, real quick.
Richard Smith here. Sorry, go ahead. Whoever was.
Just real quick. I did emissions testing for 10 years, and
Yep.
the bags are there are bags what comes out the exhaust, but there's also bags at the same time sampling the ambient air. And so you analyze them both and subtract the ambient air. And I have seen where either the air was so dirty that the exhaust bag was cleaner than the air going in. But that's about as much as the student needs to know. How do they make these measurements? Well, they measure everything. They measure the air going in, subtract that, and they know how many miles you drove or how many hours the test was. Done.
Yep. Well, I think, Russ, that the difference between qualitative and quantitative analysis is something to touch on with students, and different groups will go deeper or not as deep. What's it take to fix the truck to get it out the door? That's the question. Richard, you're chomping there, I can see.
Yeah, only just two points. I noticed over the years, off-road equipment does have somewhat of a different standard than on-road equipment. So those pieces that you're talking about, 793, 795s, 797s, in remote areas may or may not follow the same guidelines. And I remember hearing several years ago that Cummins, their systems were, and you can correct me if I'm wrong, approved more in California because the exhaust, as Russ said, was cleaner than the air going in. So a lot of people were buying them for that reason. I don't know if that is correct, but that's the logic that a lot of people were using to purchase on-road vehicles.
Yeah. Yeah, I don't know either, Richard. I know in heavy shipping, when the burning of bunker fuel in slow RPM two-stroke engines, that is still a big part of the shipping fleet, is slow RPM two-stroke burning bunker fuel that's been preheated. It's nasty stuff.
It's not the most high quality fuel for sure.
No. And you could actually see there's photos of the atmosphere, and you can see ship travel following smoke trails. So it's states like Alaska and their cruise ships, when they come into port, you can't sit there and idle on bunker. You got to have some. They'll run they keep a tank of diesel too, so they can keep everything powered up and not smoke up the whole valley.
Yeah, well, when you see it there or near Vancouver as well, when they come in, if it was run on bunker fuel, there'd be nobody standing there because they wouldn't be able to breathe.
Yeah.
That's how it is.
Yeah.
I just wanted to make sure everybody was kind of on the same page as far as off-road and on-road. There are some different regulations concerning off-road vehicles. Again, Caterpillar, Heavy Cummins. They are just a little bit different because of the atmosphere or the area that they're working in.
Well, also the size of the engine, it's more difficult in some cases.
Yeah, 3524 engine, that sucks a lot of fuel.
Yeah.
Probably a highway tractor running from New York to LA couldn't use as much fuel as one dump truck up there does in a day.
Yeah. Yep. So other discussion on this topic or anything in this past 2 days? I'm going to turn the chat on.
Just a thing on sizing of systems too. There was some issues back a while ago with guys putting in gensets or whatever, Webasto heaters on vehicles or APUs, and they were tying them into the truck exhaust system, and finding out that was causing the trucks to fail their emissions tests. So now all of those things have to have their own after-treatment system.
Yeah.
They can't be connected into the truck system. There was actually some manufacturers had to redesign their product completely to be able to do that. So
yeah, it's been a bumpy road. Those first, it was like, would you